Please have your homework out ready to turn in. If you don't have it ready to turn in today, you need to get it done, I don't know, sometime today and turn it in so that it's not late. Everybody got their homework? Done? I would check through and make sure you got it complete and turn it in by the end of the day. Hey guys, don't forget you can turn assignments in a day late. It's only 10% off, so if you turn it in Monday, it's a day late. But I do recommend that you get those assignments done on time moving forward.
I literally completely forgot this.
Is Emma not here?
She might not. I know. I just put something in.
But I mean, if you have nothing on there, just, how about this? At the end of class, when I'll put the homework back up there, put it immediately in your phone as an alarm to remind yourself to get it done. You know what I mean? Yeah. AJ, do you not have your phone? I said don't ignore your next period though and get your homework done. Hey Gabby, do you not have your phone?
Do you think
Well, I got the running man by my name.
The what?
The running man.
It means you're an athlete.
Oh, what? I didn't know that. What sport I play?
I got a medical thing. It's probably be acceptable to medical.
What the medical thing mean?
No, stupid.
All of the above.
Okay.
I used to have seizures when I was little, so maybe that's why.
Let's get started. I'm going to stop the bell ringer. Alright. Hey guys, I only had 11 of y'all finish this problem up. We need to get those equations in there a little bit quicker. Almost 8 minutes into class. Look, I know that some of us, we struggle with writing equations, that's okay. The reason why I did this bell ringer specifically was because I saw that we struggle with writing equations on the understanding check, so we need more practice with those. Don't let me forget one to pass out the understanding checks, not the ones from yesterday, but the one from last week. I'll have the one from yesterday back till Monday. I know that that's where we need to focus our attention. We will go over some aspects of this understanding check after I have a chance to analyze it. I did not get as much feedback on here as I usually like to, but I'm going to analyze the understanding checks and we're going to have specific discussion points on Monday, not about everything, but about some things. And if there's still some questions you still have, please come into tutoring, shoot me an email, I'll be more than happy to respond. But again, like I use this as information on what we need to cover a little bit more so that you can improve your understanding. I always look at how y'all are doing on specific skills to figure out, okay, what do I need to cover a little bit more so that we can get better at this. You saying that I am capable walking into my class, 1 is not a gimmick, 2 is not saying that you're going to get it immediately. It is that you are capable of growing and learning, and if you continue to grow and learn, you're going to master. Now, one thing I do want to quickly address before we get started, because I have had a couple students, specifically in 3rd block, mention, Mr. Kinney, you just don't even hear me when I talk during whole class discussion. 2 things. 1, if I don't hear you, that probably means you need to speak up. I can only hear you if you're as loud as the person next to you. But 2, this is why I do like you to raise your hand before you just shout out an answer, and that way we can have some level of order and you can have respect for each other's ideas. Keith, you don't be nodding your head like, heck yeah, right? Because I think you're one of the ones who likes to just talk and talk over people sometimes, yeah? Probably, okay. With the most love for you, right? Like we want to be aware of those things. But raise your hand, and when you hear people say an answer, be listening to those answers and think about what they're saying so that you can either add on to what they're saying or push back on what they're saying. That's, in order to do both of those things, you're going to have to actively think and engage your brain. And that's why I have the active collaboration rubric, to make sure you're aware of what helps you be successful. Talking helps you be successful. When you hear people say ideas and you listen in and you think about that, it should give you a chance to ask a question, to clarify. It should give you a chance to add on to what they're saying or to push back on one of those three things. Get involved in that conversation actively. Yes, Madison?
You turn the air out there, it's cold.
Like make it colder or make it warmer?
Make it hot.
No. Alright, so from there, let's look at this problem. We have the most common response is 1 times 3 to the x minus 1. At least a lot of us are recognizing that this is what type of function? Exponential. If you don't have this down, which these answers at the bottom were very clearly missing important details, in order to write the equation of an exponential function, what equation should you be thinking about?
A times b squared to the x.
So we need to be careful about that because we'll let whoever that is in. Remember, b to the x. That x in the exponent is what makes this exponential. That x in the exponent is what makes this exponential. I saw a lot of people on the understanding check talking about how we are squaring to the x. But the term square only means what exponent?
Exponent of 2.
An exponent of 2. We need to be careful about that. A square only means an exponent of 2. Raising it to the x is there because an exponent means repeated what? Multiplication. An exponent literally means repeated multiplication, and when the number of times that you can multiply changes, the exponent needs to be able to what? Change. Whatever this b is, that's my multiplicative rate of change. That's my multiplicative rate of change. And I need to point this out, and I need to emphasize this. Is a graph the best place to identify the rate of change? No. A table will definitely be the best option to identify rate of change. Now, you can write the equation off of here, but I will point out, one, can you really tell what the y-intercept is off of this graph? I can't. Okay? But if I make a table, maybe I could figure it out from that table. What is one clear point that I can see on this graph?
2, 3.
Okay, I can see a 3, 9.
427.
I see a 2, 3. What else do we see? 427. Is that enough information to identify what my multiplicative rate of change is? 3 times 3 is 9. 9 times 3 is 27. Okay? One quick trick that I will point out to you is, and this just is a helpful thing, the easiest way to find your multiplicative rate of change, hey, what's the inverse of multiplication? Division. So if I take 27 and I divide it by the previous number, what do I get?
3.
Because 9 times 3 was that 27. If I take that 9 and I divide it by 3, what do I get?
3.
Because again, that's what I multiply by. That is a quick and efficient way to find. Does anyone remember the name for that multiplicative rate of change? What do you say? Say it louder.
Give us a hint.
Starts with an F.
Okay.
It's a constant factor. A lot of us on the understanding check, we're talking about constant rates of change just for linear. But remember, is this a constant? Is this happening over and over and over again?
Yes.
Yeah. That's a constant factor right there. Because factors, we multiply with them. Right? And so we can continue this. 5, I multiply by 3 again, and I get 81. I can't see it, but I know that that's the pattern. In a similar way, I can go backwards. It'd be 1 and 1. Right? 1 times 3 is 3. I can find my y-intercept now. Anybody know what it'd be? 1/3, right? 1 divided by 3 times 3 is what gives me a 1. Now I can do my y-intercept. So some of us said 1/2. and you might think 1/2, but we need to have that mathematical evidence. We can say y equals 1/3 times 3 to the x. My y-intercept times the constant factor raised to the x. Some of us very successfully wrote other equations though, because that's not the only option. That's only if we have the, but what is A? The y-intercept, right? Does anyone remember the form if it's not, if you don't have a y-intercept? F of x equals y1 times b to the x minus x1. And Kaya, you may have remembered it, but you didn't just magically pull that out of nowhere. Where did you also look? So that was the Venn diagram, linear, exponential, and quadratics. Remember, the summary of everything with those 3 different functions came from that linear, exponential, quadratic Venn diagram. It's all there. Each of the different representations, each of the equations, each of those different things. So be aware of that. And that allows me to write any of these equations. F of x equals, I can do 1 times constant factor is still 3 to the x minus the x value of 1. Just looking at the graph, we could have done 3 times 3 to the x minus 2. All of those equations will work because I'm using, the first one over here is using the y-intercept, but these are just using points that are on the graph. What are your questions about that exponential function before we continue? One of the things I do need to emphasize is this. You should never, ever, ever try to write an equation by just magically letting it pop into your head. Don't do it. Write it out. As soon as you identify, hey, that's exponential, write out the equation of an exponential function. It's going to help you focus your attention. Oh, A, that's my y-intercept. Okay, maybe I don't have a y-intercept, so maybe I want to switch to this equation. B raised to the x, that helps make sure that we don't make mistakes like, nope, that's not what I want. Like, look at these equations. And it's good that we made these mistakes, but let's learn from them. Does that look like an exponential equation? No. If you had written this out, wouldn't that have helped make sure you don't make that mistake? Okay? There's some aspects here that are good. We do have a 3, but remember it's raised to the x, not squared.
That's mom.
Okay.
I swear to mom.
Does that make sense though, where what to do to fix that moving forward? Okay. What are we completely missing here? An exponent. At least this would show me the evidence that you understand what the general exponential equation is. Be careful for these. It's y1 times b to the x minus x1, and then it's y1 times b to the x minus x1. So we want to be careful that if you use that method, it's x1 and y1. Make sure that you're identifying, though, what b, the constant factor, is and what x1 and y1 are. Okay? We'll continue to practice this as bell ringers, probably until the test, because we need more practice with that. So take notes, learn from your mistakes, grow and get better. All right, from there, since we don't have questions, did anybody have the homework ready to turn in?
No.
Dang. Destiny, you got it?
Of course.
She did.
I did want to.
Okay, so again, if you don't have it ready to turn in, get it done during enrichment or sometime today and turn it in. It's not going to be a huge assignment or grade, but again, your homework assignment is something that's designed to help you practice and learn so that you are putting the skills that we need into play, and I can give you feedback to improve your understanding. All right, so we're getting back into what concept at this point?
Solving quadratic equations.
Solving quadratic equations. You cannot forget one of the most important aspects of that. If I ask you to solve an equation, what are you trying to do?
Get the answer.
But what is the answer? Well, you're solving for the variable, you're trying to get the answer, but the more mathematical way to say answer, because answer can mean a thousand different things. But if I'm asking you to solve an equation, you're trying to find the what? Solution. And that's important because the only thing that solution means in math is what? You need to write this down then. And I need you to hear me very clearly on this. Can you have an incorrect answer?
Yes.
Yes. A solution will never be incorrect. And we looked at this yesterday. What were the solutions for B? I think x was equal to 8 and x was equal to negative 14. Pick up your calculator from there, and I want us to substitute 8 in for x. So type in 8 plus 3 squared equals 121. Type in that entire equation. If you weren't aware of this, there's an equal sign right underneath the gray control button. Wait, what did it say? It's true. So Owen sees that it says true. I need some verification.
True.
True back there as well?
True.
Let's check it. True. What you wrote again? Equals what?
I swear I put
No. Is equal to what on the right hand side?
2.
Where does that say 2?
Dude, that's in parentheses.
That's 121.
I swear to go to experiment.
Alright.
Okay, it's true.
Oh, it says true?
Yeah.
Okay, let's check the negative 14. Negative 14 plus 3 squared equals 121. Type that into the calculator. What does it say?
True. True.
True again?
When it's gonna say false?
True.
When you put it into.
Okay? So let's do this. Why don't you substitute? By the way, I do want to point this out. Don't forget, to make your life easy, you can just hit the up arrow until that previous equation is highlighted. Hit enter and bring it down. You just have to change the number that you want to change. Why don't you put the number 5 into that equation?
Where?
Put 5 in for x. Substitute 5 in for x.
Oh.
So one of the things you're missing in what I'm trying to point out and you want to know is this. 5 plus 3 squared equals 121. False. Everyone else was doing this earlier, and this is what they're referring to as saying true, is telling them it's true. Okay, why don't you substitute the net number negative 2 in for x? False again? False again?
Yeah.
Let me ask you this. What numbers do you think that you will get false for the equation in B?
All that 8 and negative.
On everything but 8 and negative 14. Decimals, fractions, square roots, whatever. Okay, so 8 and negative 14 are the what for this equation? Solutions, because they make the equation true.
Correct.
Hear me very clearly on this and write this note down. Solutions are what make equations or inequalities true. That's what a solution is. It's the only thing that a solution is in math. These are values that make equations or inequalities, because they work for inequality, the idea works for inequalities too. Inequalities true.
My jeans go.
What? That's an interesting problem.
I know I need some scissors. Look at my zipper. Like, it's been over. I just moved my foot and it was on.
Somebody 8.
Okay, I need y'all to hear me very clearly on this, because this is probably one of the most fundamental terms in mathematics that people misunderstand and misuse all the time, and it creates problems. Okay? I want to point this out because it's going to tie into everything we just talked about. This is an equation, right?
Right.
So does that equation have solutions?
Yeah.
Anybody know of any solution for that equation? I see 7 solutions already on the board. Yep.
When? 2? When?
I'll point out there are 2 variables. You can't have one value for the solution.
3.
I just said you can't have one number for the solution.
0, 1/3. 2 and 3.
0, 1/3? So if I substitute 1/3 in for y, does that equal 1/3 times 3 to the 0 for x?
Yeah.
Type it into that calculator, let's find out.
He is your special student. Have you realized that?
1, yes. 2, I had a conversation with him yesterday about how
False.
it's not just my, you better check that again.
Oh, that's a multiplication.
Yes, ma'am.
What we put?
Wait, so that's true?
Yes.
Okay. Let's check, I don't know, 3, 9. Does 9 equal 1/3 times 3 to the 3rd?
We ain't put that in parentheses.
You don't have to this time around, because you're not grouping anything.
How you put it?
That's true.
That's true as well?
It's false.
True.
Split up. Oh, you supposed to put just not.
I quit.
Don't quit, learn from your mistakes, get better. So let's check this 81 equals 1/3 times 3 to the 5th. This is the last one I'm going to check.
It's true.
That's true as well?
I'm not doing it so bad.
True still, Tori? Okay.
I'm just gonna assume it's true.
You're just going to assume it's true because everyone else says it? Hey, do you know, so I'll point this out, with that quadratic equation in B, there were only 2 solutions. With this exponential function, there's already quite a few solutions. Any guesses how many there really are?
Infinitely.
Infinitely many. Do you know the way that we can see those infinitely many
Graph.
solutions? Look at the graph of this.
With a straight line, maybe?
How dare you? Does that look like a straight line to you?
No, but
What's the name of this, by the way? Because that's how a lot of us call
A
this.
curve.
Not just the name of this is an exponential curve. Don't you dare call it a curved line. I talked about that before. We still talked about it like that. But I want you to notice the whole point of this graph right here is that every point, even though it doesn't look like it is a point, the way we get this curve is that we have infinitely many points stacked up on top of each other, creating that curve. Every point will make this equation true. Even the decimal values, the fraction values, the root values, every point on this curve will make that equation true. So every point here could be called a what? Solution to that equation. All right. Does that help us understand solution a little bit better?
yes.
Hopefully. So if I use the term solution, what's the only thing I mean?
It makes it true.
It's the value that makes the equation or inequality true. Okay? So when you use the term solution, you should only let it mean what the value that makes.
The inequality, inequation is true.
Okay. Because I want that to be clear that that's what you should be thinking as well. Okay, so here's what we're going to do. We worked on A, B, and C yesterday. Use that to help you work within your small groups to complete part D. So I sent it out as a poll question. Type your answer in. If you get more than one answer, just put a comma between your 2 answers. If you get more than one answer, just put a comma between your 2 answers. I promise you, if you have the calculator already in hand, you're missing what we should be doing here. You've got to show some work with these things.
I'm so confused.
Talk to your group before you start saying, hey, I'm so confused. Look at the previous examples. Sorry you feel this way. Yeah, it's called sarcasm.
Hang on.
Was asking kids.
You would multiply. You don't know.
Yes, I
My people don't know yet.
Huh? Okay, so Brandon, why don't you tell us?
Wouldn't you multiply 18 by 1 over negative 18?
Okay, so what you're trying to do is use the reciprocal, right? Okay, because you're trying to divide. Are we multiplying by that negative 18? So it's a good idea, but are we multiplying by negative 18? Where do we go with that 18? Well, you're subtracting right now, so you need to add, because what is negative 18 plus 18? 0.
See, I told you they didn't know.
It's okay. I wanted you to talk first, and then I would help. That's how I always operate. Because I want y'all to talk. Was that 1/2 times x minus 5 squared?
X plus 5.
X plus 5? Hey, really quickly, by the way, I do want to point this out. This is a good time, like right now, you don't have to stay seated. If you want to show your work on the chalkboard or on the whiteboards, anywhere, this is a good time to get that practice and move around a little bit. It's your choice, okay? But notice, one thing I will point out is you do want to start with whatever's furthest from the variable, which that's this. But because it's subtracting, I need to add to make it a 0. And then I need to use that property of equality.
Mr. King, can I raise this?
Sure.
Tonight.
Now think about it in there, okay?
You gotta like hit the control button over there.
Third that 5, right? Do the math, hold on.
One thing really quickly, not that you're saying I just think about pointing out.
We're just going to.
Why are you multiplying? Why are you multiplying by 2? Yeah. It's the reciprocal, but the whole point is to make this a. I just want to emphasize that, right? Like, you're 100% right. I just want to make sure you understand why we're doing this. When we multiply reciprocals, because 1 times anything is just whatever that thing is.
My brain wants to go down.
You talking about it?
I don't know. She just tried to tap the board and said, hi.
0.
Okay, one thing I'm gonna call
Okay, now what?
as you're working that out.
What else you got?
No.
Something.
Mr. King, I'm on the right track.
I just wanted that word in Spanish.
Have you talked to your group at all? Because I see your group way over there and it doesn't look like you're
Hang on,
working
let
with
me.
them. If you want to work with them, why don't you erase this stuff over here and y'all can work together?
Yeah.
Look, so we have this. So you can multiply by 4. But what I'm going to remind you is whatever you do on one side of the equation, you have to do the other. Have you done this to the entire left side of the equation? No, because this is one term. So when you multiply this by 2, you're multiplying that entire term by 2. But what if you not multiply by 2? So you can do this. This is doable. But one of the things I would heavily emphasize is you want to work with whatever is furthest from the variable. And so if you think through the order of operations, what's the first thing happening to x? It's inside parentheses, so the first operation is added by. No. Parentheses. So you've got to do what's inside the order of inside the operation. So the first thing happening to x is added by 5. After x is added by 5, what's happening? After x is being added by 5.
What did he say?
What's happening? I'm not saying that you can. I'm saying that after x is being added by 5, it is going to be squared. After the square, what's happening? Remember, you gotta follow your order of operations. There's no multiplication, adding, or subtraction. And after we multiply, then we're subtracting. That is the last operation being done. That's the one I want to undo first. So that's yes.
I think instead of like,
On the guide.
I think instead of.
Can I watch this?
Okay. I'm gonna come and check on you in a second, but it looks like some of your group's working on this.
I'm sorry, I haven't used this board in so long.
Alright, so work from there. Hey, Kean.
Come here.
Have you actually looked at the work we did yesterday?
Yes.
Because we very intentionally talked about the fact that we're not gonna square from there.
Can you put your-
What are we gonna do here? Huh? That's what you're doing when you do x plus 5 times x plus 5.
What?
Can you come here?
So what am I supposed to
What are you using right here? What's that first thing that we did? We used an inverse, right, with the property of equality. Is there an inverse you can do with the property of equality? Yeah. Y'all need to pay attention to, we're gonna have a conversation about the order we need to do things, but multiply by the reciprocal.
Can you come here, sure? Alright, so I.
Quick question, what is your group?
36, yes.
Are you actively engaged in a conversation? Might be better if you're closer to, might be better if you were working on chalkboard, y'all
What
working
is that?
together. But I need y'all working together. You can write on the desk, but I need y'all actively working together.
What can I copy to my square?
I was thinking
So it's from the very beginning, so I will point this out. You're multiplying by 2
wait,
to
what
make
is
this
it?
equal. How do you do that? 1. And you can do that, but remember, whatever you do to one side of the equation, you have to do the other side. Have you actually multiplied the entire left side by 2 right now? Do you know what you did not multiply by 2?
It's like 2 divided by 2.
See, but this is one single term, so you actually don't need to multiply this by 2. You haven't multiplied that by 2. But here's it, so that gives you 36, but here, I want to point this out, this can make your job easier. What if I just add it by 8?
Now you do it.
So we don't gotta do this.
I thought you like just playing with you like, oh, it's not gonna be 36.
Oh, I know we had.
You do -5, it's not gonna be
Yeah,
36.
we're gonna talk about a couple of things about the
You would have-
pay attention when you.
Wait, no, that's not right.
Wait, are we still supposed to have
The order
And then you should-
but the order
You
back.
have it
Right, so you
squared and
multiply by
then
2
square
divided
root.
by 1.
True.
You would just have to also multiply this by 2 divided by 1, and this by 2 divided by 1.
With 1.
All together. This is why you simplify, right? X plus 5 squared minus 36, and then 0 times 2 is 0.
No, you would square root it.
You don't know what we do on stupid.
Dad, you did what I did. He's looking who went to school there. My mom was
X plus 5 squared.
So then it's
Yeah.
plus 5.
So you change left hand side, the other side by side.
And then that cancels the square out and the square root.
They could, they can.
Yeah, it cancels the square root out.
Oh, how you doing?
And then it goes back to.
Doing good.
Oh my goodness, you scared me. Yeah.
What are you doing? What are you doing from here?
Really?
What?
Stop doing it.
You do the math.
Yeah, one
How you tell me to wait?
You always do that. Don't do that.
I mean,
We talked about it multiple times.
Well, then, and then it would be X plus 5 and then you subtract 5.
do you have any? No.
Subtract?
I'm here, okay? I'm really
Do that to my marker.
You would subtract 5 on both sides.
No, I'm watching.
You can't do that. I'm trying to teach you.
Favorites, dude. Thing you done. How much page you want me to go?
So then X equals whatever. Wouldn't that be just, would it just be 36 though?
Added by 25, so you actually have to get rid of this before you can do that. In simplifying, not from the order of solving. And you also,
When you're the square root of 36.
it's just square that
It's
line.
just
And you
36.
square this, what you're doing is multiplying some.
That's it. I don't know what was the
Squaring hands, right?
It
So it's gonna be x squared plus 5x.
But still, if you what we really need is
trying to
have.
I honestly got it.
I don't know. Now I hope
You
no.
can't solve that. So don't do that.
What's it making?
From here,
Well,
If we were supposed to. Well, I can't say that. I just now got faster.
I hate it.
2 divided by 2.
No, you on the left down here.
Why are we?
It's still 2
Huh?
just magically get back with it. I
Yeah.
created. No.
You gotta do reciprocal, you
I
gotta
haven't
get it,
used
not
that.
the one
Why
hand.
didn't look at some game?
This is 1 divided by 2.
It literally posted down here said you reached.
That why you look at some.
Yeah, I think so too.
They're right. Yeah, that's right.
Yeah, I don't know.
Lita, what are you doing?
I'm asking. That's why I wrote in orange.
You know what?
That's what I'm saying, but like, what is
Why are you doing one over
I
eight?
Because I
didn't
figured
What are reciprocal?
that
Look.
anything happens.
That's what we've been doing. Taking that.
They have it right.
We already share, right?
But still,
Yeah.
you have that written down at this time, right now. So you need that. You need to quit doing that because it's unbalanced.
Yeah, I'm telling you. So we multiply by 2 over 1, and then we get the other side, which is 36.
Is this right so far?
And then we got which is 5 squared.
That's a crayon.
Thank you, thank you, thank you. So let's talk through this one a little bit. There's a couple of things that I want to check. So first off, a lot of us are saying 1 and negative 11. Oh, a lot. A few of us are saying 1 and negative 11. For those who are getting there, I see that pretty consistently. How could we check, if we think we've finished, how can I check that these are the solutions? Substitute, and it should tell me what? True. True, okay? For those who did this, did you substitute in and check to see if it said true? Yes? Perfect. So then we know for sure that the solutions are 1 and negative 11. But I want to talk through a couple of details that are getting us tripped up, and I know where they're getting us tripped up. First off, some of us did not take this critical note yesterday. When you have vertex form, what do you need to use to solve that equation?
X-intercept. Well, oh, yes.
We're trying to find the
I was gonna
x-intercept.
say.
Say it again, Madison.
Inverse.
Properties of
Inverses
equality.
and properties of equality. Ladies and gentlemen, if the equation is in vertex form, use your inverses and your properties of equality. That's it. Now we're going to talk about the best order to use those inverses in. But if you have a vertex form equation, use inverses and properties of equality. I need you to look at that getting started, and I need you to make sure you have that note down. If the equation is in vertex form, use inverses and properties of equality. It sure is in vertex form. So, let's look at this. First things first, I want to address a fantastic mistake that quite a few of us were making. Samaya, your group was definitely making this mistake. What was it?
And I'll say it right there.
It's a fantastic mistake that we need to learn from. Stop sweating it.
Okay,
We learn from our mistakes.
We had majority of it.
I know, but what was the mistake that y'all made from the
We
beginning?
multiplied by 2 over 1, but we didn't do it on both sides.
Okay, well, no, you did. So,
No.
But if you do
No,
it,
but
it's
he
still
said,
gonna be 0.
did we do it 18?
hold on.
I did.
So, one thing, and I will say this, so you could just multiply by 2. Max was talking about the idea that we're going to multiply by the reciprocal 2 divided by 1. And it's going to give us the same answer. In general, if you are used to the idea of multiplying by a reciprocal every time, that's going to be convenient. Because let's just say that this had been 2/3. I know it's not, but if that was 2/3, what should I multiply by?
3 over 2. 3 over 3.
3 divided by 2, or 3/2. And what's that going to give me?
1.
1. Notice 3 times 2 is 6, 2 times 3 is 6, and what's 6 divided by 6? 1. If you learn to use that reciprocal, it will always work to create a 1. However, here's the issue, and it wasn't just Samayon's group that did this. They multiplied by 2 and they multiplied by 2, but remember, whatever you do to one side of the equation, you have to do to the other. Have I multiplied every term on the left-hand side by 2?
No.
What's
That's negative 18.
The negative 18. And be careful. You need to multiply every term by 2. Does anyone know what operations separate terms? This is something to be aware of. Okay? Terms are separated by addition and subtraction. So this right here is one term. I'm only going to multiply that term by 2 one time. so that these create a 1, okay? But I still need to multiply this term by 2 as well. And so then you get 1x plus 5 squared minus 36 equals 0. Now, this is not necessarily the way I recommend solving it, but this would be valid mathematically if you multiply every term on the left-hand side by 2.
Wait, so every time you have a plus sign or minus sign, it's completely different as like what you call a term?
It's creating a new term. So like, if you think about the standard form of a quadratic, how many terms are there?
There's 3.
There's 3, right. Every time you have that plus or minus, and now I will say this is still one term because outside of it there's that multiplication. Does that make sense? So all of this we consider one
So,
term because there's that multiplication
Multiplication
outside.
and division, don't do that.
They don't create what we call a new term, correct? Yes.
What's the multiplication?
Say again.
What if it was like 1/2 plus x plus 5?
So, like this.
Okay, well, like, with a plus sign right after.
1/2 plus the parentheses.
1/2 plus those parentheses?
Yeah.
Well, that's the equivalent or the same thing as this. That would be 3 terms. Actually, once you simplify it, that would become 2 terms. Now, right now it's 3 terms, but I can simplify it to 2 terms. Yeah, so that's a good question. Okay, but from here, right, again, we want to use inverses. What inverse could I use now?
Addition.
Addition, negative 36 plus 36 creates a 0. And so I get x plus 5 squared equals 36, which is where a lot of this got to. Now, I'm going to talk through some finer details that are we need to really pay attention to. Man, y'all wiped out my markers.
You want this one? Oh, what?
What? Okay?
You don't know that's my kid.
Yeah. All right. So here's something I want you all to pay attention to because this is going to help you identify what order to do things in very heavily. Now, Madison was talking very heavily about PEMDAS earlier, but we need to be careful about this, and Madison's not the only one who makes this mistake. A lot of us think like this. PEMDAS is what order? It's the order of operations to do what, though?
Find the solution.
Simplify?
Girl.
Simplify?
Say it again.
Simplify.
Simplify.
You don't need
Please hear me very clearly on this, ladies and gentlemen. PEMDAS is only the order of operations to simplify, not to solve. So if I'm looking at the left-hand side, if I could simplify, when I look at x, what's the first thing happening to x?
No,
It's being added by 5. Remember, what's the first part of the order of operations? Parentheses. So what's inside the parentheses has to happen first. So x is being added by 5 first.
But you can't really do that.
You can't do that. But that's what's happening to x. It's being added by 5 first. After x is being added by 5, what's happening?
Then your exponent.
Then it's being raised to the second power. It's being squared. Because exponents come before anything else. After that square, what's happening?
Multiply, divide.
It's being multiplied because multiplication comes before addition and subtraction. And so what is the last operation happening on the left-hand side? Being subtracted by 18. The most efficient method to solve is to take care of the last operation being applied. The most efficient method to solve is to use the inverse on the last operation being applied. The last operation is minus 18. So personally, I'm going to add 18. It is not the only way, hear me very clearly on that. That is not the only way to do this, but this will be the most efficient way. At this point, what is the last operation being applied?
Multiplication.
The multiplication by,
The reciprocal.
well, the 1/2. 1/2, right? So remember, x is being added by 5, then it's being squared, then it's multiplied by 1/2. So that times 1/2 is the last operation being applied, so I'm going to multiply by its reciprocal.
So we're doing PEMDAS backwards.
That's a good way to think about it. And so now 1 times 1 is 1, and I'm left with x plus 5 squared is equal to 36. Does that get me to the same point as over here?
Yes.
Yes. This is just more efficient. There's less confusion and places to make mistakes here. Now, what's the last operation being applied? Well, the square is happening right now, so I need to take a...
Exponent away.
Well, but how do I get rid of that square? A square root. So Elijah, you said square root, but right now it's being squared, so I need to take a square root. But the question I asked is, what's the last operation being applied? The answer is that it's being squared. You are jumping to that square root. Be careful and listen to the question. Okay? The square root of that square cancels, creating what exponent? A 1. So what is x plus 5 equal to?
6.
Negative
6, no, the plus over the minus 6.
The plus or minus 6. Remember, you can make that 2 different equations. I like the single equation method. Alright, from here,
You just subtract 5.
so the inverse of that addition is subtraction, creating that 0, and x is equal to,
1.
well, hold on, negative 5 plus or minus 6. And what is negative 5 plus 6? 1. Negative 5 minus 6.
Negative 11.
That's my 2 solutions.
Hey,
Okay?
Yeah, I'm smiling.
we got it.
Alright, so we're starting to get there, but I do want you to notice these finer details do matter, that you want to go in the order that is the, where you start with whatever the last operation being applied is. That's going to be the most efficient. You can do it other ways, it just leads to more mistakes oftentimes. So you should still have those notes down from yesterday of, hey, I'm going to use those properties of equality because it's important. Does this pink equation right here look different than this final answer right here?
Yeah.
Yeah, they look very different, don't they? But because I used properties of equality all the way through, I kept creating what kind of equations?
Equivalent.
Equivalent equations. So do they give me the same solutions?
Yep.
Yes. Right? The whole idea is that I'm going to use my inverses to create zeros and ones. And I use that with the properties of equality so that I get an equivalent equation. And those are my solutions. What are your questions before we continue? Say again? Not one of those. We're going to come back. So listen to me very carefully on this. We're going to do a different skill for a little bit, and then we're going to come back and practice this with activity 5.2. So all of this will come back up in activity 5.2. But we're going to pause for a second on this and learn about another skill called factoring. I know, it's really exciting stuff. Okay, so we're going to come back actually to this number 2, because this is the first question that really goes into this idea of factoring. I do want to point out, what would y'all probably do, or what did we do for part A of question 1? Did we use Oscar's strategy of subtracting 27? No, what did we do? We added 9 and then took a square root, right? It was a little bit more efficient. Does anyone know, right, so what form do we have right here?
Right here, 36.
X squared minus 36. No. What form of a quadratic? That could either be standard or it could be vertex. But it is better to think about it as standard. What form is this though?
That's factored.
That's factored form. And so there is a strategy called factoring that's going to let us get to this point. And that's what we're about to learn about. Okay? This is a special case of factoring called a difference of squares. We're going to get into this. Hopefully this starts to come back from last year. I will go ahead and tell you I might teach this method slightly differently than what you're used to. The strategy that I use will work every time, which is the reason why I use it. And so that's something to be aware of. If you remember how you did it, that's perfectly fine. Go with what you've done in the past. But I will say that I've had some students who had me for Algebra 2 last year who've already come back down and like, I don't love the way that we're doing it right now because it's just guess and check and it takes me forever. Can you remind me quickly? And I literally showed them one problem and they're like, oh, I'm good to go. And they were able to do it immediately on their own again. The method I'm going to show you takes a second to understand, but it is very effective long term. Okay, so here it is, activity 5.1. Go ahead and turn here, and we're going to talk about this. We're going to work through this problem together. So, if this equation was in vertex form, we now know how to solve that equation. If the equation is in vertex form, we're going to use what?
The opposite inverse to reverse it.
With that,
Properties of equality.
properties of equality with the inverses, right? Remember, we need those inverse operations. The inverse of PEMDAS is the order that we're going to do it in, but we're going to use inverses with our properties of equality. Is this in vertex form? No. This is in standard form. The first strategy that we're going to learn about how to solve an equation in standard form is factoring. So, what we're going to talk about here, so right here it says solving quadratic equations by factoring. One of the things I want to point out about this title, when we say solving quadratic equations by factoring, what we're focusing on is when in standard form. The idea of factoring works when you have a quadratic in standard form. Hold on. Don't use an expo marker in your book. That's for writing on dry erase boards. Thank you. There are markers inside of the boxes if that's what you want, okay? Alright, so please understand that this idea of factoring works when you have standard form, no other time. Now, I'm going to talk about why this is the case in a second, but the very first step is what? What do we see as the first step in this worked example? They add 3 to both sides. When factoring, you have to add 3 to both sides. Don't write that down yet, because we will talk about why in a second. Okay. And they kind of just magically jump to the factored form of x minus 3 times x minus 1. There is a quick way to do that. There is. So please hear me very clearly. What I'm about to teach you is not necessarily the quick way, but it is the way that will always work. Alright? So my philosophy is instead of learning 100 different ways to do something, learn one method that works for 100 different problems. Okay? So I'm going to teach you one method that works every single time. What I'm going to teach you about is something called the AC method. Anybody know where we might have seen A and C already?
The standard form equation.
The standard form equation. That's exactly why this is called AC. And that was good, Elijah. It took me a second to hear what you said, but you got air. Okay, but the AC is coming from the value of A and the value of C. When I look at this standard form, what is the value of A? It is A is what? 1. Remember, it's A. But if you write x squared, it's going to mess you up. Remember, A is only the coefficient. A is understood to be 1.
Why are you adding 3 to 4x? -4x.
Well, remember, I told you don't necessarily understand why yet, Madison, but we need a 0 on the right-hand side, and I'll talk about that later. But so if I add 3 to create a 0, I've got to add 3 to the left-hand side as well, but I can't combine them because they're not like terms. Okay?
So b is -4.
Do I need B for the AC method?
No, you need c.
I need C, which is 3. Notice how it's A times C. So literally we're going to take 1 times 3 and we get 3. After you multiply A times C, so after multiplying A times C, you need factors that add to B. So you may have to play around with it a little bit, but does anybody know any factors of 3 that can add up to this value of B of -4? Say again. 1 and 3. I mean, so 1 and 3 are the only factors. Now we need to be careful. Will 1 and 3 add up to -4? So first off, -1 times -3, does that multiply to give me 3?
Yes.
Yes. Do they add to give me -4?
No,
Yeah.
Yeah.
I lied.
You good with that?
Yeah.
So please note, After you multiply A times C, you need factors that add to B. I don't know why I just erased that. After that step, separate Bx using those factors.
It should repeat everything so fast, like, short time.
Okay? So you're going to separate Bx using those factors. What I mean by that is, we now get x squared minus 1x minus 3x plus 3.
What? Why
Because
does it look
is
like
it because
that?
you're separating 4x?
So, I'll explain more about it in just a second about why. I'm going to have to finish this problem and then I'll show you why. But I just want you to notice, first off, is negative 1x minus 3x the same as negative 4x? Yes. So I'm separating that negative 4x out into those two factors, negative 1x minus 3x.
So if that's the case, is A and C always going to be equal to B? Like, if
The-
we're using the factors of A and C.
No, you need factors that add to B. So you need to, we'll look at more examples of this, but you have to find factors of this that add up to be B. Okay? From here, the final step is something called factoring by grouping. So finally, factor by grouping. And so you group your first two terms together, and you group your second two terms together.
Are those your parentheses in the factor form?
Almost. So we're going to group our first two terms together. Does anybody see a common factor for x squared and minus 1x?
One,
Not just one.
negative one.
Don't they both have a
X.
factor?
X.
A factor of x? So if I factor out that x, remember, that means I'm dividing the x out. So if I factor out 1x from x squared, what am I left with?
Squared.
I have 1x. Remember, what's x times x, Madison? X times x is x squared. So I factored one of those x's out. If I have minus 1 times x and I factor out that only x, what am I left with?
One.
Minus 1.
That's your first parentheses.
That's my first parentheses. Now, when I look right here, what do negative 3x
Three.
and plus 3 have in common?
Three.
Okay? Positive or negative?
Negative, positive.
Negative and positive.
So it could be either one, but, so don't write this part down yet. I want to point this out. If I pull it, or factor out a positive 3, that negative stays with the x. Do these perfectly match right now?
No.
So we don't want that. We want to factor out that negative
So you
3.
want to keep the x positive?
Well, you want your factors, you want these to match. So I'm going to factor out the negative 3.
So x minus 3?
So I'm not x minus 3, x.
Minus.
Plus.
X minus 1.
It's
Say
not
again?
equal.
X minus 1.
X minus 1, y'all.
Oh, you just said they had to match.
They have to match. 2, note, we're not changing anything. Note, what is negative 3 times negative 1? Positive 3, right? I need them to still multiply. If you had put a 3 here, what's negative 3 times negative 3? 9. Is that this 3 right here? No. If I put a plus 1 here, what's negative 3 times a positive 1? Does that match this? No. I need x minus 1.
So is the net, are you always going to factor out the negative if there's a negative, or is that just for this equation?
No, you have to make sure that these match. And you can't just make them match, you need to factor something out so that they match. Okay? And the beauty at this point is, you remember how we factored out the greatest common factor? Right? Do these have any common factors?
Everything in parentheses.
Yeah, the x minus 1 is a common factor, isn't it? So if I factor out my x minus 1, I factor that out, what am I left with?
Negative three.
X.
X